Hi everyone and welcome to TÜV SÜD's Building Information Modeling webinar for owners and investors. Tobias Schmidt is an expert in building information modeling implementation at TÜV SÜD at WIMO. Therefore, he is responsible for BIM strategy development and BIM implementation for building owners and addresses all aspects of BIM. Prior to TÜV SÜD, he was head of BIM at Cerayon, one of Europe's largest life cycle experts for technical building infrastructure, where he led the BIM transformation across all countries and across technical disciplines. Without further ado, I will now hand the presentation over to Tobias Schmidt, who will give a brief introduction and take you through the topic.
Welcome also from my side to the BIM webinar. Let me very short introduce you the topics that we want to walk through today as a kind of short 360 insight. First, we would like to show you BIM at TÜV SÜD, how we use BIM, what we set up as a team. Second, we have our BIM definitions. So I'm going to show you about how we apply BIM in our company and for our clients. Also very interesting, how to implement BIM, how to start BIM. We also have best practices for you. And last point will be a little output into the future of BIM, which we call connected BIM. So what is interesting about TÜV SÜD, since 150 years, we help to properly use new technologies and also get relevant quality, best performance, and high output of it. So 1860, when it was the first industrial revolutions, it was all these huge mechanical machines like steam machines. Today, for sure, it's more the digital technologies like CAFM and BIM for sure. So in our 150-year appearance on the market by implementing and optimizing new technologies on the side of the industry and asset owners, we rise up a team of 24,000 employees who today work in approximately 1,000 locations in the world. And what's the most interesting digit, the 43% of our revenues we make outside Germany, indicates that we became an international consultant and engineering brand. Also about BIM, we have our core markets in Europe as well as in Asia and Middle East, and followed by the Americas, which is a huge continent, but our major business on BIM we do in Europe and Asia. Here is a map where our BIM teams are located, and looking to the logo, aside of this famous blue TÜV SÜD octagon, you will see the yellow brand of Signon. So here's the explanation. While TÜV SÜD carry out BIM for real estate and infrastructure, Signon is our 100% daughter company and the specialist for BIM-based signal engineering and rail sector. So I can summarize, we have three BIM sections. One is for real estate, one is for infrastructure, which means tunnels, bridges, streets, and the third one is BIM for rail. And when I say we, I mean the so-called BIM Center of Competence. So this is our global organization that is heading all TÜV SÜD BIM services, such as consulting and engineering. In our BIM COC, we join both R&D as well as project execution, and mainly in the areas such as industry and government. So the BIM COC is the roof for a total number of approximately 280 plus experts working in BIM. And what I feel really important to say is that our BIM topics are so diverse that this intercultural, interdisciplinary work is absolutely important to cope with the quality and the performance of every BIM project. So since we have so different roles in BIM projects, like you can see here for engineering, BIM implementation, safety simulations, energy and sustainability audits, via BIM model, rail design also, the global COC is really the roof for all these BIM topics we're doing in our daily business. Building information modeling, you see that I highlight the I in BIM. So why TÜV SÜD needed to develop this new technology? I can tell you that we're not digital maniacs getting paid to be super nerds. So we came to BIM because our daily business was facing with problems that we could not solve with the classical technologies and with the methods from the past. One issue I'd like to show you is some sustainable environments. Here it's all about an lacks in resources and energy that demand us to be much faster and cheaper in designing and auditing green concepts for single buildings, but also for whole cities. So we faced with the problem that simulations and energy concepts are too expensive and take too much time to program, making the development and so on. So we were seeking a much cheaper way and a much faster way to help our clients build and operate more sustainable buildings and to implement sustainability concepts much faster and cheaper. The next big issue was to help urbanization become successful. So especially when we talk to our government clients and after we reviewed buildings, especially in Asia and in the Middle East, we found out that spaces become really critical, and at the same time, current buildings have a very high loss factor, which means that investors pay for space that's not really used and that, artificially enlarge buildings. So we were seeking for a new technology that help us to analyze and optimize spatial issues, and by this also to reduce construction costs. The third pillar that where we needed a rapid change was transportation and logistics. Here we understood that especially urban transport projects are very, very cost intensive and also long lasting. Since, for example, underground or road extension request many pre-project analysis, huge load of data understandings to be able to really design a fast, reliable and cheap public transport. So all these issues we face as a consultant and engineering organization made us to implement BIM really to turn the problems from the past into chances of the future. And since our daily business is really facing with the life cycle of all assets, both in infrastructure and real estate, our BIM services are also 360-degree. As you can see here, for example, starting with the BIM consulting, BIM strategy, followed by BIM implementation, BIM management, BIM engineering is the next issue, BIM design, we call it here, BIM training. So we really have a lot of diverse BIM tasks in our daily business. So this is why we rose up this 360 international team. About our definitions. So you mentioned that I highlighted the I in BIM, but there's another interesting item that we use, and this is so-called digital prototyping for AEC, which means architecture, engineering, and construction. So true BIM, what is really important to say, true BIM is really beyond 3D, which means that the so-called level of information that I've highlighted here plays a really, really important sector. So looking back and comparing the technologies that were used in the past years, you see that BIM is a really dramatic change. In 2D, we created just schemes of an object, really abstract. In 3D, we created views of an object. With BIM, we create a fully functional prototype of the later asset. Yes, and this means we have a virtual construction, and not only that, but we have added simulations and optimizations. And this process of digital prototyping, which means virtual construction, simulation optimization, is a very, very powerful improvement, especially for our building owners and investors. Yes. Coming back to the point that we highlighted the I in BIM much earlier, very important to say that BIM is really beyond 3D, which means that the so-called level of information is very, very important. So an empty BIM model does not bring you any benefits. This is only 3D by visibility. This is emphasized by the LOD, level of detail. Here it's all about how detailed you see the model, but the clue is to bring real intelligence right into the building models. And this goes by the so-called LI, level of information. Here it's all about the proper parametrics to run or to execute the simulations, optimizations, documentations. So, but by adding information to the BIM model that you really use for this analysis, simulations, and so on, this is a real clue. To give you a very short overview of what the I in BIM, I mean this parametric information can be, here is a short overview. So space optimizations, you already know this is about the 3D amount, spatial programs. In this area, we also have the so-called clash detections, or what we call collision-free construction, which saves approximately 2% of the average project loss. Also, we have the maximum surface and spatial efficiency due to the fact that we can streamline and optimize spaces. Later, I will show you some project references. 4D and 5D, this is about the construction period. This is not about the building, but about the construction processes, where you can track time and budget in real time. So even if you make changes by yourself about the facade, about rooms, you can really understand the, let me say, cost ratio of your changes, which also empower the design speed and also the decision speed of the project. 60, this is all about the fast commissioning and the digital working, as we call it, in the operational phase. Here, this is about accurate project documentation without, how to say, remapping or rearranging project data and lift them over to facility management. Yes. And 70, our opinion is that this is the last dimension in this chart. This is the most important, since the 70 is the KPI-oriented planning and, let me say, achievement about the life cycle. So here, this is all about life cycle analytics. Later, I will also show you some interesting aspects about this 70 issues. So if you're using BIM as the owner or investor of a building, first you make your contractor really not to see BIM as a kind of new method of documentation, but really also to use and apply the BIM model as the real prototype of the later building, which means that this can be the center for any simulations. This can be your project information model, for example, for creating very precise bill of quantities to prepare the construction period for time and cost monitoring and so on. Also very important, looking to augmented and virtual reality. This is very interesting to use the BIM model as the visual model for developers and stakeholders, because imagine you can go into the building even in design stage, so much earlier as the real building is built in reality. And last but not least, very interesting to use the BIM model as the building dashboard for financial due diligence and for technical due diligence, yes, and also for asset operation and real-time monitoring. So as a summary, I can say this is the effect that we get out of BIM if we apply it as the digital prototyping. This is faster design, much earlier simulations, cheaper optimizations, and for sure this leads to more sustainable operations. Remember, if we can add energy concepts here. So great. When we meet owners, we're often asked, hey, TÜV, give us a management summary on how to implement BIM properly. So, and this is what we have prepared for you today. I would like to give you a very short insight of the proper BIM implementation. For us, this is about 3 steps. And the first step, create use cases and optimize the ROI on BIM. So since BIM is a very big topic, I personally like the idea to create so-called use cases. And that means to identify 3 to 5 current issues that cost money to you or that reduce your profit or the building quality. We, for example, have our clients with KPIs that we set up by other projects and with the so-called TÜV SÜD process matrix. So in my opinion, I can say value-driven BIM means we find out current waste and cost processes and then seek the best BIM method and the BIM technology that can, so to say, heal your current issues. Yes, we also benchmark, this is next important issue, we also benchmark your contractor market and create a BIM transformation roadmap that gives insight which invest you need to do at which point of the project and where and when is the ROI. So the first is really about creating a BIM strategy, about use cases, about the proper BIM technology, and so on. The next step is about the real BIM implementation. Here it's about two core documents, the so-called Employer Information Requirement, EIR, and the BIM Execution Plan, so-called BP. The Employee Information Requirement streamlines your BIM strategy that you created in step 1 and gives contractor a guideline which LOD, LOI, attributes, parameters, and visibility, and also which use cases you wish to have with BIM. So the BIM Execution Plan is the guideline during the project execution to give your project manager a tool to check and track BIM quality and the BIM maturity of the project. Yes, so the Employee Information Requirement is more a tactical, strategical document, while the BP, the BIM Execution Plan, is the, executing quality management, quality assurance of your project. So this is about technical BIM implementation. The third step is about doing BIM, in engineering, in project management area. And here it's all about the BIM management, which is a very famous item today. The BIM management, remember you created the Employee Information Requirement and the BP, and now, or we as TÜV Süd, track, audit, guide your contractor while using BIM during design process, during engineering, during construction, during simulations and optimizations. So as a major aspect here is also to properly, structure and develop the LD, the information that you can use then for technical due diligence or for asset operation like COBie standards. So here this is all about proper engineering, proper setting up the BIM model, and also properly filling and adding information to the BIM model. And to make it more interesting, I like to show you two BIM implementation projects of TÜV Süd. One is for, we call it public BIM in Germany. So this is for a municipality located at Main-Taunus region. And for this German municipality, we run a so-called digital transformation project of school projects. Their major problem was time loss. So their demand, accelerate planning and accelerate the project planning and improve sustainability. And what we did was to digitalize the planning process in the way that draft models were created and used even in the what we call phase 0, which we use for lifecycle analytics and also for sustainability checks. And the BIM result is very interesting. While the project planning lasts 11 months before our audit, BIM enables to start BIM design within 14 weeks. Due to lifecycle analytics, for example, for facades or floors by using the Autodesk Tele program, it is expected to save between 10 to 20% of the construction costs. So, and about school projects, interesting that similar projects in the UK government show cost savings of BIM of nearly 40%. We expected in this Main-Taunus region school projects that BIM could save due to this life cycle analytics between 10 and 20% of costs. So again, this project was about BIM implementation to save time. Yes, and as I say, the project planning before lasted approximately 11 months, and by the project planning now, it is done in 3.5 months. Another interesting implementation project was for the industry, now not for the public sector, but for industry. This is a global manufacturer of laser and industry production solutions. He's located in Stuttgart. And here is interesting thing. So this organization planned 5 new buildings with a total construction volume of approximately 92.5 million euro, and we made BIM ROI analysis because this company was not sure if they really want to invest in BIM, because first they saw BIM as a true cost factor. So we run BIM ROI analytics, BIM feasibility studies. We implemented CAFM before we implemented BIM, because this is so-called self-operator, and he wanted to use the BIM models also for operation. What's interesting in this project, we benchmarked also OpenBIM, I mean this IFC, and native Revit, and we came to the point that native Revit brings the highest profit. So in this construction volume of approximately 93 million euro, we saw potentially cost saving of 10.2 million euro in saving with the Revit model, while we find out that the IFC but anyhow, brings 1.6 million benefits. The highest cost savings we find in the space optimization. Here it's about less construction costs and also about the energy optimization, which we found out can save 6% energy savings compared to the existing buildings, and also the data handling for the as-built documentation and the error-free design lead to this very, very huge cost savings about BIM. So summarized, I can say BIM really saves money and BIM really saves time if BIM is really properly implemented. Okay, and now I'd like to make it a little bit more, practical, and show you some best practices, projects that we did. And I will also have some very interesting projects of our partners. First project I'd like to show you is the so-called New South Glasgow Hospital. So the state health organization of the UK called NHS, National Health Services, refurbished and built a huge medical campus with 2 hospitals. So before this refurbishment, the NHS analyzed all their 107 existing hospitals about energy consumption. And in this area, especially electrical power and energy consumption for HVACs. So these existing conditions monitoring was the basis for energy KPIs for the all new BIM projects that we executed. NHS came to us with a very, I can say, crazy idea to cut down the energy costs by 25%, which is really, really much. But after we take the BIM models from contractor, analyzed it, and about material spaces, and also rearranged the MEP layout, we found a way to cut down the energy cost by 50%. Really, 50%, this is really, really much. And this was also very surprising for us. So now the campus asset have a footprint of 60 kilograms CO2 per square meter per year, which is probably the lowest CO2 amount for hospitals in this range. And here's how we do it as a schematic approach. First, we use the simple conceptual models to streamline spaces. Later, we use the room models to rearrange room layouts. Then we're using the MEP models to optimize HVAC systems layout. And then we use the so-called construction model to optimize materials. And with this 4-step analysis, we really get the point that we could save 50% of the energy costs. Space efficiency. This is what we also show you before. So how we do it here, this is the so-called St. James Center. This is a multifunctional complex located in Edinburgh, UK, and really interesting that here we collaborated with our facility management experts who advised the engineering on facility management processes and FM layout of the MEP systems. And due to these, spatial optimizations of service alleys, and we came to more compact space alleys, but at the same time we care for a better operability HVAC layout. We could save a total of 8,500 cubic meter space volume that save approximately 9 million construction volume, and also downsize the energy by nearly 25% due to use spaces. So here, this is very important to understand that the space optimizations really cut down both loss factor and by this construction costs, but really also help to increase the energy level and to get a higher energy certificate. This is a screenshot I did for you from this spatial audit. You can see that we both implemented the systems in gray and also the, space needed for maintenance and repair. And by this, they really allow us to streamline the whole service area, the whole building area, and so on. And by this leads to a high saving of space, and due to this also construction costs. This is a very interesting project from our partner. This is so-called BPS International. They were asked to carry out the BIM project of Park Huamin. This is a Chinese investment project located in Moscow. A huge building. It's approximately 100,000 square meter use space. And here they also played with the basis of the HVAC system, and by downsizing, not downsizing, but they created this two-story layout of the central HVAC unit and transformed 1,000 square meter that was used for this, let me say, central HVAC unit to a use space. So the investor was very happy to transform this space that was getting free from this technical space to 4 apartments, and he sold it for $4 million. This is really interesting point because the BIM mandate and all just cost only $650,000. So this is really nice profit. So you really understand that the spatial optimizations really play a really major role in this BIM execution. Battery power station, I think this is a project that some of you might really know. This is a very famous project located in London, and this was the old, I think even this was the largest power station in the UK from the early 1920s, 1950s, now transformed to a living quarter. And the phase 1 includes 2 apartment blocks with 750 and 100 units. Our task was to care for the MEP design and also for the spatial optimization. What we were asked, since the investor wanted really fast start selling and handing over the apartments to the new owners, so he wanted really to speed up the sales process, we were asked to speed up the construction process, and we find out that if we use the so-called prefabrication function of BIM, we could really both save average 10% of construction time for the investor, and at the same time, due to prefabrication, here is a list of prefabrication use cases that we use for these projects. We could really upgrade also the construction quality, which is really, really relevant, because if you only start constructing or assembling all these parts at the construction site, this can lead to component loss, component quality lags, and so on. So this prefabrication really brings both benefits for the construction quality, but as we saw, also 10% saving in construction time. Here is the next interesting point if we talk about speed. Here it's about design acceleration. This is again the project of our partner BPS International. They were asked to care for the architecture of South Russia's largest airport located in Rostov. And what's interesting, this project was planned for 4 months from the to develop the conceptual design to construction design. So the contractor or the building owner appointed for this task 4 months, and he ordered 8 architects. What's interesting, due to the parametric approach that also on the side of the architect or engineering company automates this daily process, it's really impressive that BPS needed 4 months but only 2, so half time to develop this really sophisticated architecture from conceptual to construction design, and not with 8 architects but with 2. So this is also our expertise when we do MEP design, that BIM, due to this parametric approach, really fully automates, for example, replacement of components, creation of bill of quantities, and so on. So this is really impressive, and by these 2 projects, you see that both construction can be accelerated, but also, as you see in this airport, the design phase. And since we have a little bit time, I'd like to get you a output to what will be developed in BIM in the nearest future. So today we talk about the BIM model, and the model itself always indicates a kind of rigid, static thing. But interesting, we transform where now we're engaging to transform the digital prototype into connected BIM. We have partners. Again, this is BPS International as one of our, let me say, engineering developers, and we're using Autodesk technologies to rise up this solution. So connected BIM really means we take this digital building prototype and lift it over to the building dashboard in facility management. For example, for multi-team collaboration, for AR, VR, for simulations, for operational facility management, and so on. And connected BIM, because we're adding sensors to the model. The test lab for this is the Country Park 3. This is the building of BPS International. And the small image you see here, this is the facility management office where the Revit model runs as a live model for collaboration of the facility management. And very easy to plug in sensors into the BIM model to carry out the so-called preventive service. So no longer predictive service, which is approximately 7 to 10% of the OPEX, but we really think to use the BIM model for operational facility management to analyze systems in real time, not to send, for example, mechanics every day there to have a, let me say, short-term eye-to-eye check to the existing pump or conveyor, but really to use sensors to real-time monitoring the devices every time, 24 hours a day, and by this big data really gain a better understanding of how we can save energy in the building, of how we can save cost for facility management in the building. We're using so-called sensors, and we're using a cloud connector. And here is a short overview of use cases we can track or we can evaluate with the sensors. So this is all about the atmospheric conditions like temperature, carbon dioxide, humidity, pressure, vibrations. Vibrations, very interesting to care for facility management, intensive pumps, noise also, light, positioning, and also orientation. And what we found out that as soon as we talk about the BIM models that really have full, how to say, building knowledge, the full building inside, and if we're now on top talking about operational data, we found out that it's really, really crucial to have a very safe data storage. TÜV SÜD acquired a company called Uniscon that provides what we call secure data platforms. And we're using this secure data platform to operate or to install our BIM services there. That means in TÜV SÜD on this Uniscon servers, our BIM models are running, and not only our BIM models, but also the operational data we evaluate with a BIM2 sensor strategy. I mean, here it's all about tracking the performance and reliability of building systems and so on. So connected BIM also helps for commissioning. Here we made a shortcut from commissioning of a laboratory, and maybe you can see it, this model. So this is during the soft launch of this laboratory, and here's the central technical unit that we lifted to the roof of the building. And all these small yellow, how to say, worn marks that you see on the screenshot indicates that the system still have a problem. So anyhow, this digital commissioning that we carry out with BIM and sensors helps to shorten the soft launch time. In this laboratory, it was planned for 24 months, and we cut it down to 6 weeks. Because imagine if you have sensors that really measure every second the performance and the criteria of the systems. It's possible for technicians to very, very fast understand where to adjust the components, how to set them up, and so on. So, as I say, this connected BIM is not only a gadget for facility management to reduce facility management costs, but this is also very, very interesting to use as what we call digital commissioning.
So besides this webinar, you can find more information about building information modeling on our website, for example, videos, white papers, and so on. So look out for future webinars and more information on the website, or email us at realestate@tufsud.com. Thank you for your time and have a good rest of the day ahead.